It's nice to be here. I have to warn you, I am not going to be talking about Web3 or crypto or AI. I'm going to be talking about really boring, just Git command line bullshit. So I hope that you guys use Git on the command line, because otherwise this is going to be pretty boring talk, and it's a little bit nerdy. But I've been giving talks on Git for, I don't know, 15 years now, for sort of as long as I've been professionally using Git. And I've been talking about Git again more recently. I've been doing it for a long time, but more recently I found out that a lot of people have been using. How many people, raise your hands if you've never used anything other than Git as a version control system? Okay, so this is a different generation than when I first kind of was giving talks like these. And so I thought it was kind of interesting that Git can do a whole bunch of things that you may not know about. Now, I called this talk So You Think You Know Git, but actually it's So You Think You Know Git Part 2. Did anybody see my FOSDEM version of this talk? Okay, so I didn't want to do the exact same talk. That was kind of my plan. You go and you give talks, and you don't, you can give talks multiple times, but my other talk kind of got a lot of views on YouTube, and so I didn't want to give the same talk again. So this is actually So You Think You Know Git Part 2, Git Revenge. It's exactly the same format as the other one, so if you like this talk, you can go on YouTube and watch another 45 minutes of this same exact type of thing, but I'm not covering any of the same topics. So it turns out that there's a lot of dumb shit that Git does, and I can talk for hours about it. So a little bit about me. I was one of the GitHub co-founders. I wrote the Pro Git book. If you read the, if you go to the Git website and read the book, that was my sort of open source book. And now we're working on a new Git client, which is also source code is available on GitHub, and I'll talk about that a little bit later. But I've been working in Git for a really long time, and I found it really interesting how many things it can do, and that you probably don't know. So there's more than 145 commands in Git. There's actually one introduced in the last release this week called Git Replay, which I'm not going to talk about today because it's a little bit boring. But there's just keep coming up with new commands. So there's a lot of them you probably don't know. There's still an average of 10 commits, 9 commits a day, every year. So there's always more stuff going into Git. But most of you probably learn 5 commands, and you use those same 5 commands, and you don't kind of go outside of that. Everybody's nodding. They're like, I do know those 5 commands. So there's 10,000 commits in the last 3 years. What has been happening, right? How much of this do you actually know? So I'm just going to give you a bunch of stuff that Git does today that you may not know about. I'm going to just do it as a shotgun buffet of here's a bunch of stuff that I'll talk about today. If you don't want to take notes, if anything you find is interesting, I put these slides up at the blog at GitButler, so you can go and find the slides and look up any of this stuff. So just try to see if there's anything that catches your attention, and then you can go look it up later, or we can talk about it over beers tonight. Okay, so I'm just going to hit them. One is there's some new commands in Git called switch and restore. Does anybody use switch or restore? Handful of people? Okay, so one of the things that's sort of problematic about Git that people have been complaining about for a long time is that checkout is very overloaded. So you can do a lot of stuff with checkout. So you can switch branches, checkout branch. You can revert a file, check out the file that'll revert it to whatever the version is in the index. You can revert a file to an older version of the file. If you say, here's an old commit, make the file look like it looked like in that commit instead of what it looks like now. You can also, I don't know if you know this, you can patch checkout files. So if you do checkout-p, it'll do this interactive thing, and it'll say, do you want to revert this hunk and this hunk and this hunk? You don't have to do the entire file, which is kind of cool. But again, it's checkout, and none of these things are really checking out anything, right? It's reverting stuff, it's switching stuff. So Git kind of put these new porcelain commands in that just wrap this. So instead of writing git checkout branch, you can say git switch branch, and it'll switch into that branch. And they've renamed some of the options to it, so you can say -c, which is essentially like git checkout -b. It's create a new branch and switch to it, right? I don't know what -c stands for. It could be create, it could be cat, who knows, right? Like the people who write Git have some interesting ideas from time to time, so it could stand for pretty much anything. But switch is one. The other is restore. So instead of saying git checkout file in order to restore the contents, you can say git restore file, and it does exactly the same thing, essentially. It's just, they're just trying to make it so it's a little bit easier for new users to say, don't learn these 5 things that checkout does, learn these ones that are a little bit more domain specific, and the options have changed to be a little bit more clear what they're doing. So if you want to restore from an older commit, you can say -- source and then do it from that file, and that'll work too. And the -p and a couple of the other commands. But it just splits it up. So if you're teaching somebody Git today, you might want to teach them switch and restore rather than checkout and all of the different things that it does. Okay. If you want to remember what these are all the different things that you can do with restore, checkout, switch, and reset. Checkout and switch, you can switch branches. Restore and checkout, you can undo unstage changes. Restore and reset, you can undo stage changes. Reset and switch, you can move the head reference. And all of them, you can actually accidentally delete shit in your working directory. So just if you need to remember that, this is a handy guide for you. The next thing I want to talk about is hooks. How many of you use hooks in your Git repositories? So there's lots of things you can do with hooks. I don't know if you know how many hooks there are. There are 28 hooks that you can use in Git. I'm not going to talk about all of them. I just want to talk about, actually, let's get rid of the email stuff. I assume most of you aren't sending email patches to mailing lists. Let's get rid of the Perforce Bridge stuff. You probably don't care about that. Let's get rid of the server stuff. You're probably not running your own server, right? You're probably using GitHub or something. And Microsoft introduced a bunch of large repository scaling stuff that has some hooks in it that even they don't really use anymore. So what we're really looking at is these 11 hooks. So you can do stuff around your commits. You can do stuff around rewriting or like rebasing or merging. And you can do stuff around switching branches or pushing. But you probably don't want to go into .git/hooks and write your own scripts. You can do that. That's how that's how Git tries to use them. But there's better ways of using hooks that are much more interesting. So these are some examples of what you can do with hooks. You can help with commit message formatting. You can install packages after you change something. You can update C tags, right? And switch to tabs or spaces. You can lint stuff. You can make sure you're not committing large files. There's all sorts of stuff you can do with hooks. But there's two things that I've seen used that I think are really valuable now, which help with managing hooks. One is a package called Pre-Commit, and the other one's a package called Husky. Pre-commit, essentially, you install this program. You create a YAML file that says, here's the hooks that I want to do. So you're not putting the files in. You're saying, here's what hooks I want to run. And then you install this thing. And then every time that you commit after that, it'll run those. And the YAML file looks like this, which is kind of cool. So it's almost like a gem file or something. It points at a repository and says, this repository has a whole bunch of hooks that are defined in it, and these are the IDs of the hooks from that repository I want you to run when I'm doing stuff, and they can hook into any of these parts of your work cycle. So you can say, okay, these are sort of the standard ones and some of the hooks I want to run, and then I have this other one called black in there. And then when you commit, it has this nice output, and it says which ones ran and which ones passed and which ones skipped and stuff like that. And since the YAML file's in your repository, everyone on your team can share them and use them as well, which is much nicer than trying to pass hooks around to people and have them use it. And then the other one is Husky, which is very similar. It's an NPX thing, and you can keep your hooks in a .husky file, and anybody who runs that, it'll run those hooks. So mainly, this is valuable for sharing hooks with other people on your team and making sure that everybody's running the same linters or the same hooks when they're running stuff. The next one I want to talk about is attributes. How many of you have a .git attributes file in your repository? I'm getting less and less, fewer and fewer people doing these fun things with Git. So attributes is a way of telling Git certain things about file extensions in your repository. So I'll give you a real dumb example that I think at least shows you what it's capable of doing. If you do git diff and you have two images and Git sees it as a binary file, it won't show you the difference between the images, right? It can't really do that. It says it's binary. I can't do a diff on this like I can with a text file. So I just say, hey, they're different. But something you can do is you can run files through an intermediate and then diff that. So for example, you can use something called exif tool on an image. It'll give you some metadata about an image. And then you can say, if anything that ends in .png, use this exif diff tool, and what the exif diff tool is just run exif tool, right? And so what it'll do is it'll run it through that and then diff the output of that. So instead of saying A and B differ, it'll say here's a difference in the metadata of the files, right? Which is not the difference in the files exactly, but it's more useful than A and B differ. So it just gives you an idea of some stuff that you can do. And how this works is it runs things through called smudge and clean filters. And so what this does is if you have some files and you say everything in .txt, run it through a smudge, and then it will run it through this program and then put it in your working directory. And then if you say, you add or you commit, it'll run it through another filter before it puts it into your repository. So you can do this on all sorts of stuff. One dumb example would be to implement something like RCS keywords. There's something like half of this audience has never used anything other than Git. But if you're really old, like I am, and you've actually used tools like CVS or RCS, they used to have these things where you could put these little headers into your files, and then when you check out the files, it'll fill them out, and then when you commit them, it'll clean them back out again, right? So you can say, here's the version, or here's the last commit, or here's version history, or something like that. So when you check it out, it actually looks like this, but in the source code itself, if you look at it at GitHub, it doesn't have any of this data on it, right? So you can do something like this in Git if you wanted to. You could, write a file that expands the date, and then just say, hey, I have this filter called dater, and the smudge is to run it through this program. The clean is to run it through this Perl expression. And then if you put this string into a file, and you say, hey, for everything that ends or all of my files, run it through this filter, and then you check it back out, it'll have expanded that out, right? So you could do this type of thing. It's a very simple example that none of you will probably want to do, but it gives you an idea of what you can do. The biggest usage of this is a program called LFS. So if you're using Git LFS, this is how Git LFS works, right? It works with this Git attribute stuff. Git LFS is large files, so if you're working in a gaming industry or you have large gaming assets or something like that, you don't want to put all of that into Git, because then when you clone, you get every version of every large file, and it's not very good at that. So what you do instead is essentially you store pointers in the repository, and then you have these smudge and clean filters that check them out and put them back in. So if you use Git LFS, and you install it, and you track something, what that does is it updates your Git attributes file. And then if you do something like commit a movie file or something like that, it doesn't actually store it in Git and push it to GitHub. It pushes it to whatever your LFS server is, which also can be GitHub, but in a different way. But the actual file that it stores is 3 lines, right? It's not the entire movie file. It's just sort of this pointer. And then when the smudge filter looks at it, it says, hey, okay, you have a smudge filter on this. Here's the SHA. I'll go out to some third-party server. I'll pull down the movie file, and I'll put it in your working directory as though that was what was stored in Git. So that's how LFS works. But again, you can do all sorts of stuff with these filters. Okay, I have no idea how much time I have because we started a little bit off. I have like 10 more minutes, right? I'll just pretend somebody in the back gave me a green light on that. So another fun thing is fix-up commits. So how many of you use a rebasing type workflow rather than a merging type workflow? Okay, so it's 50-50-ish. You guys are wrong, but that's fine. But if you do use a rebasing type workflow, there's a really cool thing you can do. So one of the things that I think GitHub kind of messed up is the way that we do pull requests. It's really difficult. You do your commits, you do a nice series, you say, okay, I've documented my 3 commits and stuff, and they're really nicely documented, and I push them to GitHub repository and open up a pull request, and now I get feedback. And if I get feedback, and it's feedback on the first commit of the 3, it's really difficult to fix it, right? To sort of amend that commit and add those, whatever the review is, into that commit. What you usually do is you say, hey, I fixed some review stuff, right? And you add a 4th commit on top, and you push it up, because you don't want to force push a branch or something like that. But if you didn't want to do that, if you wanted to, say, clean up your series, put the review into the appropriate commits in your history that you had, and be able to fix that up, it's really difficult to do, because what you have to do is you have to sort of interactively rebase and say stop at each thing and pull in the new changes and commit it there, and blah, blah, blah. So Git actually has a really easy way of doing this that you probably don't know. I'm actually, sorry, I keep pulling I'm curious what audience, who uses fix-up and auto-squash? Nobody. 5 people. Okay. So what you can do, if you wanted to do the workflow that I was talking about, is let's say that we have this patch series. We have some branch. It has like 5 commits on it. That's my nice series. I push it up somewhere. I get some review. Somebody says, hey, add this to the documentation, right? So I can say, okay, I'm going to add something to the documentation. I'm going to commit it. But instead of sort of rebasing and trying to figure out where to put it, I can say, commit this, but -- fixup, and then I give it the SHA of the commit that I want it to be added to, right? So I want to fix up this commit with sort of whatever I've done in this last commit here. And then it's just -- fixup. There's other things too you can do, like reword, and there's a couple different things that you can do, but it's essentially adding to the commit history. And then what it does is, it's actually kind of simple. It does this, right? So it just creates a new commit that has a very specific commit message in it that gives Git information later. So it does keep adding to the history, but then you can say git rebase -- auto squash, And you used to have to do -I and do this interactively anyways, and it would essentially do an interactive rebase, but move things around properly so that it would squash them properly. But right now, you actually don't need to do that. As of 6 months ago or something, you can say rebase -- auto squash, and it will just rebase it. And then if you run git log, you can see that all the SHAs changed, right? It actually did rebase your series, but it took you can do this with multiple. You can have 5 or 6 fix-up commits, and then auto squash everything, and it will do the rebase automatically. If it has problems or something, it'll stop, and you can fix it and rebase continue or something. But it's actually kind of a really nice workflow if you're trying to keep a patch series clean. The other thing, if you're doing a rebase workflow and you're trying to keep your series clean, you can use something called update refs. And the way that this works is if you rebase stacks of branches. So if you're doing stack diffs, if you're using something like Fabricator or something like that, right, where you're trying to do stacked branch or stacked diff workflows, stack branch and stack diffs are essentially you're doing lots of different branches that are kind of on top of each other, right? And so the downside to this, I actually don't use this very much. I don't really love this. Most people do it because it's easier to review sort of on GitHub because it kind of splits up. Because GitHub, you can't really review commits. You can only really review branches. And so people like stacking branches to make them act like commits, right? Which is kind of funny. But if you're doing that and you have these things and you want to change something down at the bottom, the downside of this is if you merge in patch 1, you just get patch 1. If you merge in patch 3, you get all 3 of them, right? They're all dependent. So if you're doing merges or something, it's a little, but whatever. It doesn't really matter. If you're doing that and you want to rebase something that's at the bottom of this, it's a little bit of a pain in the ass because if you rebase this, what will happen is it's not going to move the references of the other commits, right? It will just move the reference of whatever the one you were on when you did the rebase. Even though it does rebase the whole series, it doesn't actually move the pointers of the other ones. So recently they introduced, so you can see these are exactly the same ones, but some of them are they're off. And so what you have to do then is manually move the pointers yourself, right? I see some people nodding. There's a handful of people that are, most of you are real bored right now about this. I can tell. There's like 3 guys that are like, oh my God. So that guy over there is gonna love the other YouTube video too. So if you say --update refs, what it will do is essentially what you assume it would do, right? Is it says, hey, I saw that there were some references on commits that I just rebased for you, and so I moved them for you, right? So you don't actually have to do that. And so if you do it, it just does what you assume it should do, and it moves the references for you, and it'll move a whole stack. You can also, if you do this, actually, whether you do this or not, it's not a bad thing to just globally add this configuration because honestly, it's probably a better default. But Git doesn't want to be backwards incompatible, so it tends not to. You have to add all of these sort of updates. Okay, just like 2 more things. Scaling Git. So if you have a huge repository, like hundreds of gigabytes, right, or hundreds of thousands or millions of files in your working directory. There's a whole bunch of work that Microsoft has done, almost exclusively Microsoft has done recently to try to scale Git to be able to do Windows development on Git, right? And all of this stuff has been upstreamed, and so it's all available in Git. And I talked about this in my other talk a bit. I'm not really going to go into it except to show you a command that ships with Git now. So if you install Git, you get 2 top-level commands. You get Git and then the 145 sub-commands that Git will run. And now you get a second one called scalar. And scalar is only used to clone, essentially, but to clone very, very large repositories. So if you go on your computer, I'm actually curious how many of you have this on your computer and don't know. Has anybody ever heard of the scalar binary? Not one person in this audience. But it makes sense, right? It's mostly used if you have massive repositories, but in my other talk, I talked about all of the things that it does. I'm not going to talk about any of that other than to say, if you clone with scalar, it will set up all of your defaults to deal with huge repositories. By default, that is, you don't have to set 5 other things. So if you're curious, you can, it's a Git command. You can go on Git SCM, like you can read about the thing. But essentially, all you have to do is say, instead of git clone, you say scalar clone, and it sets it up a little bit differently, but it sets up all this stuff. It sets up prefetching, it sets up commit graph generation, it sets up your file system monitor for fast statting, it sets up a partial cloning. You actually won't get all of the files checked out by default. You have to individually say, here's the 3 subdirectories that I want, and it does sparse checkout. So yeah, anyways, if you have a huge repository, check out Scalar. It could be an easier default for setting up large repositories. And then the last Git thing that I'll talk about is work trees. How many of you use work trees? Okay. 5 people. So work trees, this is because of what I'll talk about next, which is what GitButler does. I get this type of thing a lot of, why aren't you talking about work trees? And partially it's because nobody really uses work trees, but they can be very, very valuable to some people. So work trees, essentially, it's to enable to let you to work on more than one branch at a time. So if you, for example, this is probably very common, you have a feature. Did I set off an alarm? Did I steal something? Okay, I'll wrap up if that's what that is. If you want to work on a feature, is this going to go on as long as I can do? I can be, okay. If you want to work, oh, Jesus. If you want to work on a feature and then somebody comes in and is like, hey, we need a bug fix, right? And then you're like, okay, well now I have to stash everything and kind of create a new branch and switch it and fix it and push it up and stuff like that. Work trees help you not need to do that because it allows you to provide a new working directory for each branch that you want to work on at the same time. And so the way that works is very simple. You have a couple branches. You say git work tree add, give it a branch name and a directory, and it will check out that branch into a new directory. And then you can go work on it in that directory. And the cool thing is, if you commit in that work tree, and then you go back to your original one, and you say, what are my branches? It'll show you the branches that you're working on in other work trees, right? So it's a shared object database. You don't have to kind of move objects back and forth. Anything you do in any of them is visible in all of them. And you can push from them and things like that. Okay. And you can list out your work trees, and it says, here's all of the different work trees that you have. I don't actually think that, it says I have a minute left. I think that's somebody stealing something. Actually, everybody keep an eye out for somebody looking shifty and running around like this. So the last thing is, the other way to solve this is with the project that I'm working on, which is called GitButler, which kind of solves the same problem of working on multiple branches at the same time. Except instead of giving you a different working directory for each one, we allow you to do all of them in one working directory. And we just remember what hunks go in which virtual branches and let you commit to them. So it looks kind of like this, where you have a different lane per branch, and you can just kind of drag changes or files from one lane into another. And when you commit, it looks like essentially that's the only change that was in that branch, like you were on it by itself, right? So it's kind of nice in that all of this is in one working directory. So this is a branch. I can commit. You can see there's a commit thing in each lane individually, so I can commit and change and update and stuff, all of them individually, push. And when I push, I get a different branch on GitHub for each one of these, right? So it's kind of like stacked branches would be dependent. These are completely independent branches that live together. So it's almost like taking a merge product and then separating it out into branches, right? And the nice thing is, since they all live in one working directory, you know that all of these branches will merge cleanly because it has to, right? And so this is how we're working in the project that we're working on. And you can find it on GitHub as well if you're interested in the project. So that is pretty much it. If you thought that was interesting and want to hear 10 other things, random shit that Git does, you can go to our YouTube channel. There's a video from my FOSDEM version of this talk. Other than that, let's get a beer tonight. I would love to hear about your workflows, about your Git stuff. Thank you very much, and have a very, very great conference. Thank you.